In this lesson, you will learn how to solve systems of equations with 3 variables. The previous systems we did just had 2 variables like x and y. These will have 3 different variables. You can still use those methods that we used before. You can use elimination or you can use substitution. I will do an example using both. So I have the first equation up on the board right now. The first thing that you want to do is label these equations as 1, 2, and 3 so that you can keep track of your work. It is really important to do that because once you make a mistake in these, it's hard to go back and find your mistake because the problems are so long. So since I'm using the elimination, I'm going to pick any 2 equations and eliminate a variable. So when I look at number 1 and 2, I could easily eliminate z, so I'm going to go ahead and use 1 and 2, and then I'm going to have to go ahead and pick 2 more. So number 1 is 3x minus y plus z equals negative 15. I'm going to rewrite number 1 and number 2. I can eliminate z by adding, so I'm going to go ahead and add these. So 3x plus x is 4x. Negative y plus 2y is y. Those will cancel, which is what you want, and then this will equal negative 14. Let's go ahead and call this equation number 4 just so you can follow. Now I need to pick 2 more equations to eliminate a variable. You can use any other 2, just can't use the same ones. So I'm going to go ahead and choose equation number 1 and 3. Okay, so I'm going to go back and write equation number 1. And number 3. Now, I have to eliminate the same variable I eliminated here, otherwise you're just going to be in the same spot where you have 3 different variables. So I'm going to eliminate z. To eliminate z here, this is a negative 2. I need this to be a 2, so I'm going to multiply all of this by 2. So now I have 6x minus 2y plus z equals negative 15. And then I'm going to go ahead and rewrite the other one under it. Okay, so I'm ready to add. So here I would get 8x plus y. Oh, I forgot to put a 2 here. Wait, 3 times 2 is 6, times 2 times 2, and I also forgot to multiply that by 2, so that's a negative 30. Okay, so now I have 8x, y equals negative 30 plus 0 is going to be negative 30. Okay, and let's call this equation 5. Okay, so hopefully you're following. So step number 1, pick 2 sets of equations and eliminate the same variable. Step number 2. Use the new equations to solve for x and y. So you've already eliminated 1 variable, so I'm going to use equation 4 and 5 and continue to solve this. So equation 4 has 4x plus y equals negative 14, and equation 5 is 8x plus y equals negative 30. I can easily eliminate this. I probably would eliminate y. You could choose to just subtract everything, but for the sake of consistency, I'm just going to go ahead and multiply this first equation by negative 1 and write it right here. So I have negative 4x minus y equals 14, and then I can add these 2. So 8 minus 4 is 4x. This is eliminated. Negative 30 plus 14 is negative 16. And look at that. I can easily solve for x now. So here I get x equals negative 4. Here is one answer. Okay, now that I know x is negative 4, what you want to do is go back to that equation you just used, that set, and get y. Okay, so now I can get y by plugging it in into either equation 4 or equation 5. I'm going to go back to equation 4 and plug in x. So 4 times negative 4 plus y equals negative 14. And then I just need to solve this. So here's my second variable, y is 2. Now I need to get z. You can plug x and y into any one of these equations and it will be the same answer. So I would probably pick a positive z that's easy to solve. So I'm going to go back to equation number 1 and then I'm going to plug in x. Let me go ahead and write the equation. So this was our equation number 1. I know that x is negative 4, so substitute that, minus our y, which is 2, plus z equals negative 15. So this is negative 12 minus 2 plus z equals negative 15. This is negative 14 plus z equals negative 15. Add 14. And you will get z equals negative 1. This is your third variable. Just like before, you're going to write these as an ordered pair of x, y, z. Okay? So our final answer would be negative 4, 2, and negative 1. So you can see this is a really long problem, but that is how we solve using the elimination method. Next, we're going to do an example where we solve using substitution. So now we're going to work on number 2. For number 2, I'm going to use the substitution method. So for substitution, what you want to do is use the other two, pick 2 equations and solve for 2 different variables. Take those 2 variables that you solve for and plug them into that third equation that you did not use. So let's see if that makes sense. Again, I'm going to call this equation 1, equation 2, and equation 3. So when I look at this, for the first one, I have too many, this is a z. I have x, y, and z, so it's probably not a good one to use for substitution. However, when I look at equation 2 and equation 3, I only have 2 variables, so that's great. This is where substitution works really well. So I'm going to start with equation 2 where I have x minus 3y equals 0. I can easily isolate x here. I could do y, but I don't want to do that because I'll have a fraction because of this 3. But the x is just x, so if I move y to the other side, then I know that x is the same thing as saying 3y. Let's call this equation 4. So I already used equation 2 to solve for x. Now you need to use the third equation that you haven't used to solve for a different variable. So I could either solve for y or z. So here I have negative y plus z equals negative 55. I'm going to go ahead and solve for z. Yeah, because if I move z, if I isolate the y, I would have to divide by negative. It just seems longer. So I'm just going to go ahead and add y to the other side. So we have z equals negative 55 plus y. So here is my equation 5. Now, I've isolated z, I've isolated x. You are going to take these and plug it into the equation you did not use for substitution. Here I used equation 2. Here I used equation 3. So the only one I did not use is equation 1. Equation 1 says that x minus 4y minus 5z equals 35. So, did I solve for x? Yes. X is the same thing as saying 3y. And then here I solved for z. So I'm just going to drop this for y. Minus 5 times z. Z is the same thing as saying negative 55 plus y. And this equals 35. Look at that. The only variable we have here is y. That's why we do that. So you pick one where you isolate one variable and then you isolate another variable and then you go back and plug it into the third equation, so you only have one variable. Now to solve this, I just need to simplify this. 3 minus 4 is negative 1. Here I'm going to go ahead and distribute. So I have negative 5 times negative 55. That's a positive 275, so that becomes a plus 275, and then negative 5 times 1 is negative 5y equals 35. By the way, I got this negative y here by combining that. Now I can combine negative y minus 5y to get negative 6y plus 275 equals 35. And this is a simple linear equation, so subtract 275. You will get negative 6y equals, so 35 minus 275 is negative 240. Divide by negative 6, and you will get y is 40. Great, this is one of your answers. Now go back and plug it in to find x. I can use, or you can find z. I could plug it 40 right here and I can solve for z. I could plug in 40 right here and solve for x. I could plug in 40 right here and solve for x. So actually that's what I'm going to do because x is already by itself. So x equals 3 times y, so 3 times 40, which is 120. Great. Now I have my second variable. All right, I can do the same thing here. Yep, I'll do the same thing here. Look, z is by itself. So z equals negative 55 plus y, which is 40. And you will get negative 15. Okay, so again, write your answers as an ordered pair of 120, 40, and negative 15. So this is the solution to this problem. So that's how I would use substitution. I would know to do substitution when I start seeing equations that are missing a variable, but it comes down to a matter of preference. Which one do you prefer? Which one are you more comfortable with? That is the one you should go. You should take your time so that you do not make mistakes. Like, you see how long these problems are. So if you do make a mistake, it's going to take you a really long time to figure out what that mistake is. All right, now I'm going to do an example where we'll either have no solution or all real numbers or something like that. Just one of those special ones that we already covered. Okay, so I'm going to go ahead and clear my screen and write out another example for you. So this would be our example number 3. And x minus 2y plus 4z equals 0. Okay, for this one, if you start seeing too many variables, I'm going to go ahead and definitely use my elimination or addition method. Let's go ahead and label these. So remember, pick any 2 equations and then use those to eliminate a variable. So right here, looking at this, I could definitely use equation 2 and 3 to eliminate x. Okay, let's just rewrite it. I'm using 2 and 3. Okay, I can eliminate x here by adding. That's another way you can see. Can you look around to see if there's one you can easily eliminate? Then I would use that. So I have negative 5y plus 5z equals 11. So let's call this our equation number 4. Now I need to use 2 different equations to eliminate a variable. I can't use 2 and 3. I can use any other set. So I'm going to go ahead and use 1 and I guess it doesn't really matter. Okay, I'll just do 1 and 3, okay? So I have 2x minus 4y plus 8z equals 2. And for this one, I have x minus 2y plus 4z equals 0. So I could eliminate x by, because remember here I already eliminated x, so I have to eliminate x again so that I can have a system with just y and z. So I know I need to multiply this by negative 2. Okay, let's come back up here. So here I have 2x minus 4y plus 8z equals 2. I just rewrote that, and here I'm going to do negative 2 times x is negative 2x Negative 2 times negative 2 is a positive 4y. Negative 2 times 4z is a negative 8z equals negative 2 times 0 is 0. Okay. So now I can add. That's going to cancel. Negative 4 plus 4 is 0. 8 plus negative 8 is 0. So I have nothing left on that side here. I have 2 plus 0 is 2. So my variable has been completely eliminated, and 0 does not equal 2. Therefore, my answer is no solution, just like we did before. Or you can just say void. If I would have gotten the same thing, I would have said it's all real numbers. So that is how we solve systems of equations with 3 variables. I encourage you to read the notes so that you can further understand this, because this is one of those more difficult topics.